Look at that.
Hey.
Benjie's here.
Hey, everyone. I am only able to see you, though, Lee.
Yeah, you know, I'm the best dressed one here, so what do you got?
It's a fair comment. Well, I shan't say too much about myself because I'll be saying that in a moment in the video. But yeah, I'm super excited that we finally have a GraphQL conference, official one from the foundation. That's great. I'm going to see if I can mute myself on the actual conference stream because it's confusing me. Where's the mute button? Never mind. So I have just created with Gem my this new specnewspod.com. So the idea is it's the latest news from the specification working groups. We are trying to compress it down into sort of 5 to 10 minutes. So far we've managed to do 5 to 8 minutes, so pretty condensed for a 2-hour meeting. But yeah, by all means, check it out. Stay up to date with the working group.
That's awesome. I feel like, yeah, I don't know if you can hear that from the mic on the computer. In the audience, you heard clapping. People are excited. Specifically clapping from Matt Mahoney. He's very, very excited to have the audio Spark notes. I was going to say, in every board meeting, I report back to the board, all of our member companies to the foundation. They ask, how was the last working group? What did you guys talk about? And I do like a report where I just ramble, and it's usually 5 to 8 minutes, so it sounds about right. We ought to record me rambling, and then you can just post that, but I'm sure you're much better at it with a plan. I don't have a plan, I just ramble.
Well, this is what I was saying. Like, I used to do this with Gem, so I'd turn up to the working group and take the notes, and then afterwards I'd just give Gem a 10-minute ramble of what we talked about. And I thought, why don't we turn this into a podcast?
There you have it. Well, that's awesome. I should have added that. So I had a slide I talked about in my last presentation, talked about how our working group meetings, they're obviously open attendance, but we record them, we put them on YouTube. We take these fantastic notes, or more specifically, you take the large bulk of those notes. We have other contributors, but you're helping us run that, so thank you. But of course, like reading the notes it's a lot. There's a lot of notes. It's like kind of a line by line of what everyone said, which is very helpful when we want to look back. What did we say about that exactly? It's like, well, Lee said this, and then Matt said that, and then Benjie said this. It's like, oh, okay. And the YouTube are, of course, 2 hours long because that's how long our meetings are. And it's painful enough to sit through a live 2-hour meeting, let alone like watch the recorded version. So I think you've hit a sweet spot with the 5 to 8 minute summary, which is, those meetings are always like very interesting. But unless you're participating, maybe not 2 hours worth of interesting. But there's certainly 5 to 8 minutes worth of interesting.
I think so.
All right. Well, Benjie, anything else you want to say other than launching your podcast? You've got a room full of folks who's excited to see your pre-recorded talk.
No, just want to say have an absolutely fantastic conference, and I look forward to seeing you all next year.
All right, Benjie. Well, we miss you. Thank you for joining us virtually here for a few minutes so everyone can see. In fact, you are an alive human and not just a pre-recorded video. So thanks for being part of the live event. And thank you for recording your talk and everything else you do. Bye-bye, Benjie.
Cheers, everyone. Bye.
That was our announcement. All right. Well, here we go. This is Benjie's conference talk. Enjoy, everybody.
Hello, everyone. My name's Benjie. You may know me as a member of the GraphQL Technical Steering Committee, as one of the people that takes the notes at the GraphQL Working Group, or as the maintainer of PostGraphile. I'm incredibly disappointed to not be able to join you today at the first official GraphQL conference. Unfortunately, I can't travel at the moment on health grounds, but I look forward to meeting you all in person next year. In the meantime, I'd like to tell you about Schema Metadata, which I see as a growing need in the GraphQL ecosystem. Now let's start by looking at some use cases. In your application, you may well allow users to order data by some custom criteria. And if you do, it's quite likely that you use an enum, such as this one, to allow that. Now, the values that you use in that enum and the values that you put in your sorting dropdown, for example, are unlikely to be the same text. Likely, you're using a friendly label for the actual options that you display to the user. Wouldn't it be nice if our GraphQL schema could represent this by attaching label metadata to the enum values themselves? If we were to do this, then as we add more sort options to the GraphQL API, the client can automatically represent them in the dropdown, displaying everything it needs to. We could even add translations for all the different languages. This would be incredibly useful. Another thing that we have in our GraphQL schemas when we're pulling down lists of information is pagination. We want to often pull down just a limited set of our data, maybe the first 10 records, but it's very uncommon to see the limits of this specified. Can I ask for the first 1,000,000? Is that okay? It would be nice if the GraphQL schema gave us a way to represent metadata saying that you're allowed to request 100 or you're not allowed to request more than 100. And this would be great if it was done in such a way, rather than just through the description, that tooling could pick up on it as well and could spot when we've asked for too much data or done something else that isn't allowed. Speaking of tooling picking up on things, wouldn't it be great if when we looked at a field in Graphile gave us a customized query that we could use to query this field to demonstrate to users that are new to our API how to use this field? I think this would be an incredibly helpful way to help users get on board with your API, especially if they're not already familiar with GraphQL. Another thing is, as you add things to your GraphQL API, you may well want to leave yourself space to change them when you're not really certain that this is what you want to end up with. Once you add something permanently to your API, you want it to be stable for a long time, but you still want to be able to do experiments on new features. Wouldn't it be nice if you could mark something in your GraphQL schema as experimental and indicate that this should not be used in production, but by all means go ahead and try it in development? And have tooling pick up on this fact and prevent a production push that uses an experimental feature. If you use Apollo Federation, you may already know that it uses a number of custom directives to indicate metadata about your schema, saying which things are provided or required and what the key fields are for a type and so on. So this is another key use case for metadata. Now, I'd like to take a moment to talk about introspection. One of the things that I love the most about GraphQL is that it has a specification, and a very thorough specification. What this means is that we can rely on the facts that are in the specification, that any schema, any API that implements the GraphQL specification supports all of these things. And so we can use all of this powerful tooling, the code generation, the linting, the IDE integration, the graphical tool for exploring it. We can use all of these things with any GraphQL API, and I think that is incredible. Now, section 4 in the GraphQL specification talks about introspection, and that tells us what is in our schema, what are the types, what are the fields, and so on. If we look through that, we'll find that it tells us that the _schema type tells us about all of the types in our schema and which of those types are used for the query, mutation, and subscription operations. It also tells us about all of the directives in our schema. If we further dig in and look at the _type, then we'll find out what kind that type is. Is it an object or an enum or a scalar? And what its name is, what its description is, what fields it has, what interfaces it implements. If it's a union, what the possible types it can be are. If it's an enum, what its values are.
if it's an input object, what its fields are, and if it's a non-null or a list, what type is it a non-null or a list of? Recently, we've also added the specified by URL field that for custom scalars indicates how that scalar behaves. All of this combines to enable tooling such as Graphile to indicate details about our GraphQL schema and to expose the documentation that you see above, and to allow us to write queries and see the results of those on the side. We can even click around and browse through our documentation and basically see everything that we need in order to understand our schema. Now, as we add new features to GraphQL, we are also adding new fields to the introspection schema, such as the specified by URL that I mentioned before. And what that means is that there is no longer any single GraphQL introspection query that can fully introspect any arbitrary schema. If we use a modern introspection query with a legacy schema, then it just won't run at all because it won't pass validation. It references fields that didn't exist in that schema. Similarly, if we use a legacy introspection query on a modern schema, then although it will work, it won't be able to represent things that it didn't understand, again, such as the specified by URL. So instead, we have this two-phase introspection. Our first query determines which features the GraphQL schema supports, and then the second query gets the full description of the GraphQL schema. Now, since this is a growing need for metadata in the GraphQL ecosystem, there are a lot of people that already have some solutions to this problem. Let's take a look at what some of these are now. The first one I want to look at is extending the introspection system itself. If we look at GraphQL Ruby, for example, it allows us to extend the schema type, the double underscore schema type, by just extending it like any other class in Ruby. We just add extra fields to it. Similarly, in Hot Chocolate, here's an example that I pulled off of Stack Overflow that shows how to add the additional info field to an enum value. Now, extending the schema in this way does have a number of trade-offs. One is that it might require three-phase introspection. First of all, finding out what features the schema supports, then finding out what types and fields the schema has, and finally issuing another query that introspects, that gets the result of these extended introspection fields. Another issue is technically the GraphQL spec doesn't allow you to do this. So it's not something that a schema is expected to support. And you can read more about that in GraphQL Java issue 2221. But finally, one of the issues with it is that it has the potential for introducing breaking changes. For example, if you were to add a field to the introspection for the double underscore type, and then we, as the GraphQL specification, were also to add that field, maybe it has a different type, maybe it accepts different arguments, then that would result in a conflict. Now, in the case of a conflict, the GraphQL specification would win and your schema would be broken. So ideally, we'd like to let users not get into this situation in the first place. Another solution that we see out there in the GraphQL ecosystem is the SDL field. Most typically, we see this used with Apollo Federation. Now, keep in mind that Apollo Federation has a very specific use case, but I'd like to analyze this SDL field and see if it's useful for the generic representation of metadata in our schema. In Apollo Federation, they add an underscore service field at the root of the query type. And then within that, they add an SDL field, and that contains a string representation of everything in your GraphQL schema, all the types, all the fields, all their arguments, and these additional metadata directives. Now, one of the trade-offs of this approach is that it breaks the equivalence between introspection and SDL. Normally, everything that you need to know about your GraphQL schema is represented through introspection. But here, we would need to actually request the SDL field and extract from that these additional directives that aren't represented through introspection. It also requires tooling in the client. Because the SDL is returned as just a string, we need to be able to lex that and parse that and understand it in the client, which would potentially add quite a lot to our bundle size. It also breaks clients when a new GraphQL syntax is added. If their lexer and parser doesn't support this new syntax, then it's going to throw errors. And yet it's just a string field, so it doesn't look like it should be a breaking change. This is problematic. It also is a very all or nothing approach. The SDL describes the entire GraphQL schema and has all of the information in it. So there's no way to specifically say, I'd like to know just the directives for this particular type, please. In introspection, we can do that with the _type field in the root of the query. But with the SDL field, we could not do that. It's also somewhat redundant. Most of the things in the SDL field are already there in introspection. All the types, all the fields, all the arguments, all the descriptions. The only thing it's adding is those directives, and yet it's adding an entire new piece of complexity to the GraphQL schema for it. And finally, it also pollutes that main schema with fields that our typical users don't want to be querying. We don't want to have that stuff show up in the graphical sidebar, for example. This is stuff that only tooling should be worried about. Another solution that we see out there in the wild is putting markup into the description that represents our additional metadata. So, for example, we might have something like this that uses a directive-like syntax to represent your metadata. We might use something like HTML comments because they're valid in Markdown. Keep in mind that the description is Markdown, so we must be careful. This also has a number of trade-offs. One is that the description itself is intended to be user-facing. Do we really want users to be dealing with reading things like these directive syntaxes in our descriptions? I don't think so. Another issue is that we still require additional tooling to parse and interpret this markup. And this tooling has to be aware of Markdown because all of our descriptions, according to the GraphQL spec, are Markdown descriptions. And so also, whatever we add must not conflict with the Markdown syntax, which is quite complex. This again doesn't allow us to select just the metadata that we want. So for example, if we just want those English translations of the labels for our enums, there's no way to do that. We just get everything for this particular field or type. Another potential solution would be to indicate what metadata there is in the schema using Userspace fields and types. So there's a lot of different ways that you might build this. Here's one. You could add an introspection metadata field to your query type and have that represent a list of introspection metadata. Maybe that indicates which thing the metadata is attached to via a schema coordinate. You can read more about schema coordinates in spec issue 735. And then you can indicate metadata. And that metadata could be with a union or an interface or whatever you need to represent what you have. Now, one of the biggest issues about having this user-space metadata is that it's in user space, which means users can define it however they want. Tooling can't necessarily rely on it. Just because it has this field doesn't mean it fully implements whatever specification we may have for it. It also potentially requires this three-phase introspection, and it pollutes the main schema with these additional fields that we don't want normal users to have to worry about. But one of the bigger issues for me is that it requires reassembly. We have the schema introspection data here, and we have the metadata here. Once we fetch them both, we have to mush them back together again ourselves, which is something that we shouldn't really have clients need to do. Most of the rest of GraphQL is self-consistent and you can just explore an existing object directly. Another solution that we see in the ecosystem for this is applied directives. This is implemented in GraphQL Java, Hot Chocolate, GraphQL.net, and various other implementations. Now, suggestions of what it should look like do differ, but here's an example. We can extend all of the double underscore types in the GraphQL schema, so double underscore field, double underscore type, double underscore enum value, etc., and give them all the applied directives field. This would take a list of all of the directives that have been applied, and we indicate for those what the name of the directive is, or maybe the directive reference itself, and the arguments to that directive. Now, this approach also has a number of trade-offs. One is that directives use input types. So how are we going to output those as part of our introspection schema that uses output types? Well, this is something that we've already solved with default value, in which we use a string. But we might also want to consider using something like JSON or something like one-of, but maybe these things aren't ideal. If we were to use string, which is what all the current implementations do, then we're going to require that client-side parsing again. And what that means is, again, if we introduce new syntax, it could break existing clients that are just requesting this regular string field. Normally, when we introduce functionality in GraphQL, we add new fields for it so that existing clients are unaffected. This breaks that pattern. Now, of course, we do have that same issue with default value already, but it's very rare for a client to actually introspect the default value, figure out what it means, and use that information. Normally, it just wants to know whether it's present or not. Another issue is because we're using directives, we're using input types, and at the moment, we don't have any forms of input polymorphism. Now, we might get them maybe with the one-of directive that's currently RFC2, maybe with other input unions in the future, but for now, we don't support polymorphism on input. And another issue is it, again, does not support this subselection. If you've got large amounts of metadata, all these different translations, for example, you can't just pull down the English translation. Now, I've kind of guided you down the wrong path potentially here. I've been very leading. I've shown you everything using directives so far. But are directives really the right approach? Well, the first thing that we have to consider with directives is which of the directives should we even expose in our schema? And clearly it shouldn't be all of them, because many GraphQL schemas use directives as part of their build process to indicate things like permissions or other secrets that we don't want the clients to know. So maybe we'd use a keyword like exposed or public or meta next to the directive to say that this directive should be exposed through the schema. Another option is to use an additional symbol when we apply the directive, maybe a bang, for example, that says this application of this directive on this field should be exposed to the built schema. Another option would be to eschew the word directive altogether and replace it with something like directive. Maybe use a different symbol for directive, like a plus rather than an at. It might work broadly the same way, but by using a different keyword and representing it in a different way, it's clear that this differs from regular directives. But are directives even the right approach anyway? One thing is that metadata is informational rather than instructive. Directives tell you to do something, whereas metadata describes something. They're different things, really. Another is that, as we mentioned before, directives use input types, but the introspection system uses output types. So if we want to be able to represent this metadata in a complex type way, we really need to be using these output types, not these input types. Another thing is that directives are optional. They don't have to be applied anywhere. So there's not really an easy way to indicate to a client that you guarantee that a directive will be applied to every single enum value or every single input field. And that means that you have to put a little bit more effort into how you build that tooling that relies on that information. But the most important question for me is, can we even model all of the metadata that we want to represent with directives? We've already seen that directives don't support polymorphism, at least not yet. Do we need polymorphic metadata? Do we need to be able to do sub-selections on our metadata rather than pulling down the whole thing all at once? Maybe we need to apply metadata to places where directives don't support. Now, this isn't necessarily a big problem because we can just support directives in more locations, but it does warrant thinking about. And another question is, do we want to be able to attach metadata to built-ins? Like the ID built-in, we might want to indicate through metadata that it will always be in UUID format, let's say. At the moment, we can't attach directives to built-ins. So this is something that would be interesting to think about. Here's some use cases. In a client, it's very common, especially a single page application, to want to be able to validate data on the client side before sending it to the server. Having this kind of shared validation that is ran on the client and then later ran again on the server is a common need, and it allows us to give the user the absolute best experience by telling them whether their data is valid or not before they even submit any forms. Now, when we want to represent this, the rules tend to be quite diverse, so it's common to want to represent this with a union. And I think this is a clear indication of something that wants to support polymorphism in the metadata sphere. Another thing to consider is when we want to actually browse more and more information about something. Say, for example, we wanted to know about the history of a particular type in our GraphQL schema. We might want to know which Git commit it was introduced with, or which pull request it was introduced with. We might want to know when it was elevated from experimental to full publish status. We might want to know who was the person who last touched it, and what other things have they changed recently. And in this way, we may want to recurse through the data that's available to us. This is not something that we can do if we use input types. Now, I've been thinking about this problem for quite a long time, and I don't have a concrete solution right now, but the closest that I've got is the user extendable meta types, which I'd like to tell you about now. So in this, we would change the GraphQL specification itself, and we would add a meta field to all these introspection types, the double underscore type, double underscore field, double underscore enum value, and so on. And they would all have a meta field which would be of a particular type that we would be able to extend. Then in our application code, in our GraphQL schema code, we would extend these meta types and we would add our own fields to them, things like the is experimental or the validations that I was just talking about. And this allows us to indicate that these fields are present, will always be present with the not null, and so on. So this approach has a large number of advantages. One is that we can fully represent all of our metadata needs. Anything that can be exposed through a GraphQL schema can be exposed through this metadata system. And because of that, it supports polymorphism. We can also allow sub-selecting just the parts that we need of this metadata, pulling down just the English translation and not worrying about all the other ones, which means that we are getting a lot more efficient data fetching. And this makes it more useful for situations like the client situation that I mentioned before, where we just want to know what to put in this dropdown and don't want a full description of the entire GraphQL schema. Another thing is the not null allows us to guarantee the presence of metadata, which simplifies building our tooling because we no longer need to check for nullability or handle that situation. And because this is all part of the introspection schema, it's not going to pollute that public schema. It's not going to show up unexpectedly in the sidebar of Graphile and confuse our users. However, it does have a number of drawbacks. One is that we can't currently represent empty types in the GraphQL schema. This is disallowed by the GraphQL specification. There have been proposals in the past to lift this restriction, and we could do so if we had a good enough reason to. But for now, we could just add a single field inside of that to make sure that it's not empty. Another drawback is one of the benefits, which is allowing this recursion. Now, if we allow this recursion, then it may be impossible for us to fully represent our GraphQL schema via schema definition language. And further, it means that tools like Graphile can't necessarily fully explore this metadata themselves. They may need user guidance, especially if we're using things like arguments on our fields as well. Another issue is that extending introspection types just doesn't feel right. It's something that we have been telling users they're not allowed to do for a long time. And if we change that rule, we must be careful in how we do so. We must be very careful with how we communicate. It just doesn't quite feel right to me. But the biggest issue, I think, is that it breaks that schema definition language and introspection equivalence. You can no longer take everything that you can represent in introspection and then build an SDL file from it, because we might need to explore those parts of introspection dynamically. Now, we can potentially work around a number of these issues by adding validation rules. For example, we could add a validation rule that forbids recursion. We could add a validation rule that forbids arguments. And that may solve a number of these issues, but I've not yet thought fully through these problems. So this is something I'll continue to explore over the coming weeks and months. So let's talk about next steps. We already have a RFC for this. We have issue 500 in the GraphQL spec repository. And this was opened by Oleg, who sadly is no longer with us, back in 2017. And you'll notice that it's already RFC 0. What we need to do next is raise this to be RFC 1. To do so, we need to identify a champion. We need a clear explanation of the problem and the solution. We need illustrative examples. We need some spec edits that represent what should be happening. They don't have to be final, but we need at least the beginnings of them. And we need to identify the concerns, the challenges, and the drawbacks. Now, I hope that this presentation has actually helped with a large number of these, though the solution itself is still not clear to me, and probably not to you either. So that's something that does need to be solved. What I would like for you to do is, if you have interest in putting metadata into your GraphQL schema, please get involved in issue 300 in the GraphQL spec repository, linked above. So if you can submit there your use cases, what metadata do you need to represent in there? If you can submit what you think a good solution to this problem would be. And also, if you look at the solutions that have been raised in that issue and the solutions that I've outlined in this presentation, and say what concerns you have with them, what challenges and drawbacks you see with them, that would be incredibly valuable. You can also reach out to me on Twitter or GitHub, or also on the Discord for GraphQL via Benjie. Thank you very much for listening, and I hope to see you all next year.